What if the universe physically refuses to let you kill your grandfather? Not because of morality, because of math. And by the end of this, you'll see why the real paradox isn't time travel breaking reality. It's reality breaking time travel first. Before we go on, if you find this sort of thing worthwhile, a like, a comment, and a subscribe genuinely help. Here's the classic version. You build a time machine. You travel back to 1925. You find your grandfather as a young man before he's met your grandmother, and you shoot him. He dies. He never has kids. Your parent is never born. You are never born, so you never build the time machine, so you never travel back, so you never shoot him. So he lives, so you are born, so you do shoot him. The loop tears itself apart. This is the grandfather paradox, and physicists have been quietly obsessed with it for almost a century. Because time travel into the past isn't obviously forbidden by physics, Einstein's equations actually allow for it. Certain solutions to general relativity contain what are called closed time-like curves, paths through space-time that loop back on themselves. On paper, you can trace a route from tomorrow back to yesterday. The math shrugs and says, sure, why not? So the question stops being, can you travel back? The question becomes, if you did, what would stop you from breaking everything? In the 1980s, a Russian physicist named Igor Novikov proposed something startling. He said the paradox doesn't happen because it can't happen. Not that you're forbidden from trying, but that every attempt fails, every single time. This is called the Novikov self-consistency principle, and it works like this. The universe only permits histories that are logically consistent with themselves. If your time trip leads to a contradiction, then that trip, as you imagined it, has probability 0. It simply doesn't occur. But trips that form a consistent loop, those are allowed. So imagine you go back to shoot your grandfather, the gun jams. Or you miss. Or the person you shoot turns out to be a stranger. Or you get there and realise the man you thought was your grandfather was actually his cousin. Anything goes wrong. Not because a cosmic hand slaps the gun away, but because out of every possible sequence of events, only the self-consistent ones actually get to happen. It's like the universe is a novelist who refuses to write plot holes. Here's where it gets beautiful. In 1991, physicists Fernando Echeverria, Gunnar Klinkhammer, and Kip Thorne, yes, the same Thorne who won the Nobel Prize for detecting gravitational waves, ran a thought experiment with billiard balls. Imagine a pool table with a wormhole on it. A ball rolls into the wormhole, comes out earlier in time, and smacks its younger self off course. Classic paradox. The younger ball now never reaches the wormhole, so the older ball never comes back to hit it. Contradiction. But when they actually did the math, they found something wild. There were always self-consistent solutions. The ball would come out of the wormhole and give its younger self a glancing nudge, just enough to send it into the wormhole at a slightly different angle, which is exactly the angle needed to come out and deliver that nudge. The system found its own loop. And here's the twist. Often there were multiple consistent solutions to the same setup. The universe apparently has options, as long as none of them are contradictions. Now, some physicists find Novikov's answer unsatisfying. It feels like the universe is cheating, engineering coincidences to protect its own storyline. So in 1991, physicist David Deutsch proposed a quantum version. In his model, when you travel back in time, you don't return to your own past. You slide into a parallel branch of the multiverse. You shoot your grandfather in that branch. A version of you never gets born there. But the you who pulled the trigger came from a different branch where your grandfather lived, had kids, and raised the future assassin. No contradiction. Just two universes that don't quite match. This is elegant. It also has a strange side effect. In Deutsch's model, closed time-like curves let you solve problems that are otherwise impossibly hard. Factoring huge numbers, cracking certain codes. A time machine becomes a shortcut through computational difficulty, which might be a reason to suspect nature doesn't allow them at all, because if it did, the universe would look very different. Stephen Hawking took a different route. He suspected the universe doesn't police paradoxes because it never lets you get close to one. He called this the chronology protection conjecture. His idea, whenever you try to build a time machine, say by twisting space-time hard enough to loop back on itself, quantum effects blow up in your face. Virtual particles pile up around the would-be time loop. Their energy density spikes toward infinity. The whole region rips itself apart before the machine can switch on. Hawking said the laws of physics conspire to keep history safe for historians. It's not a paradox resolver, it's a paradox preventer. The universe never even lets you get in the room, so we have 3 answers to the grandfather paradox, and each says something different about reality. Novikov, you can travel but you can't change anything. Deutsch, you can change things but only in parallel timelines. Hawking, you were never going to travel in the first place. You might think this is just clever philosophy dressed up in equations. It isn't. The grandfather paradox is a stress test for physics itself. General relativity and quantum mechanics don't fully agree with each other, and time travel is one of the sharpest places they collide. Whichever answer turns out to be right, self-consistency, parallel branches, or chronology protection, it tells us something deep about how space-time and information actually work. There's even recent work by physicist Germain Tobar suggesting that events near a time loop would naturally recalibrate to stay consistent, without anyone needing to intervene. Free will preserved, paradox avoided. The math just quietly reshuffles the details. Which brings us back to your grandfather. If you travelled back with a loaded gun and murder in your heart, and Novikov is right, you would fail. Not because you'd change your mind, but because in the only version of history that gets to exist, you were always going to fail. Your success was never on the menu. So here's what I want to know. If the universe only lets consistent stories happen, does that mean your life right now is already one of those stories? A loop that closes because it has to? Or do you think Hawking was right and time travel is simply off the table forever? Drop your take in the comments. I read them.